Yeah, look for tongs. And this one. Hopefully you can hear me. I'm just going to getting the fire going half the time is the problem half the time. So I already kind of started it, and sometimes it can take a while. So the main idea of this today is for the archaeology students. I was just going to do a square nail, just so they can see a forge and how it's all set up. I've never seen a forge. I don't know if people can hear me or not. I've never seen a forge that wasn't set up this way. It's the forge is usually to the left, anvil in the middle, and a leg vise to one side. The forge is usually a permanent fixture of stone. The anvil is usually on a pole or even a tree stump that's into the ground, and then the leg vise would be off to the side. So usually there's a triangle in the remnants of the forge, I would think. And a lot of times, before you start any fire, you have to pull out what they call clinker, which is a byproduct of coal. So some of the stuff, once it's been dug up in an archaeological dig, the clinker was all meshed together. That's probably another way to identify a forge has been there. So in this I will do an old square nail. This is one that came out of a dig. And then this is one that came out of a dig, and I just heated it, brushed it, and you can see that it's old iron. You can see all the layers from the old iron. And this is one I just made. So this could be 100 years old or more, I'd say, probably 200 years old. Doesn't look much different. So the things you need is a piece of stock metal. So I'm sure any scrap metal that would have been left around, they would turn it into stock, shape it into a rod. Some sort of a tool with a hole in it. Usually it's the square hole. You heat the metal to a point. You hammer it to a point. You put it in till it stops. It's too thick. You cut it off, and whatever is red that's left on top, I'll just basically smash that down to the head of the nail. So I'll heat up a bit of stock. I don't need that much fire. It's just going to burn away the coal on the top. So I'll spray it on the fire and try and make it like an oven underneath. When you put new coal in initially, it'll flame up. Add a bit of fresh coal and you'll see it will flame up every time. And then the coal will fire, but eventually as it cooks, you deprive it of oxygen, you can coke it down, they call it. It turns to coke more than a coal. And as you're hammering the steel, there's different colors of temperature. If you hammer it when it's too cold, you'll end up with cracks in your steel, especially if you were to do a blade or something like that. It makes it harder, but it can make it more brittle as well. And in a nail, you definitely don't want that. So I'll heat it up to a nice high temperature when I work it, and I won't quench it. and I'm done, because that'll also harden it. So I'll just let them cool. And I'll look on my phone to see every now and then if anybody's got a question. I don't know if I'll be able to see it or not. Try not to put my phone in the forge. I've never had my phone out while I'm doing it, so hopefully I won't. You can see at the top it's yellow. Getting close, and it's redder down here. It's obviously much hotter at the end, and that's where I need it. I need it all yellow. Turn the fire, the air down each time, so I'm not just wasting my coal. Each time I go to pull the steel out of the fire, I'll turn the air down. Since this is round stock, and I want to stretch it out, I have to square it off, because you can't draw out round steel. It needs to be square. As it cools off like that, down to that orange color, I need to reheat it. Now I have to be careful, as the tip gets narrower, that will heat faster than the thicker steel. So I have to put it all the way in through the fire and have the tip out the other side of the fire. But obviously it heats much faster each time. Every time you try and clean off your anvil, because where I'm working just two sides back and forth, the other side, which is the anvil, is helping to shape it. And if I leave all that slag on the anvil, that's what will leave an impression on the hot metal. Now, if I were to start to see sparks, like a sparkler, a certain type of sparks, it would mean I'm burning the steel, burning the carbon out of the steel. You have to pull it out of the fire right away as soon as you see those sparks. Some items might be ruined if you let it get to that point. Then I get to this point. Getting nice and orange. Clear off the anvil. Work down to the point now. Now when I get to this point, Each time I get close, I put this in to see how far. So that's the length of the nail now, which would not be nearly long enough for the thickness of the nail. So I need to draw it out much more. But you see the difference between the round stock that I started with and where it's square now. Hence the square nails. Maybe I'll burn one afterwards and show you what it looks like when it starts to burn. And if I want to make a copy of a nail, I can just leave another one right alongside, so I know how far to go with the drawing out of the steel. And you don't have to worry about too much about it being even and bent. You want to get the size first, then you can go back and quickly straighten it out, shape it afterwards. Still have plenty to go. Now right now I have an electric blower on it. Makes things much easier. But I also have a, I can show you after, a set of bellows that are a couple hundred years old. And I can interchange it as an example, which I'll do some other time. I have my bellows on wheels, and I plan to make a large mobile forge and other ideas to use the bellows. And too much talking is making it go slower. The more I let the steel cool down, the longer it'll take me. Yes. Yeah. Hello. Yes. Oh.
The juice we just mentioned is not open.
Okay. It's not?
It's open for me. It's blurry sometimes. Like
It says it's not live.
I have the sound for that.
Try Evans. So people are watching. So does that mean I am live? I got a call saying that I wasn't live. But it says people are watching, so
It's a bit blurry every now and then, but
you think it's live? Do you see?
yes, you are live, it says. Yes, you are live, someone just coming.
Oh, okay. Alright, we'll keep going. I think it's good and hot. Almost there. See, the narrower part is heating up faster than the end, so I got to be careful how far I put it into the fire. All right. Basically, I'm trying to work out what's going to be left for the head of the nail now. Almost the same. Now if you're outside, you'd see a big puff of black smoke whenever I put new coal on. I've had neighbors come to me and ask what I'm burning. So each time I put on new coal, I gotta spray it with water and coke it up. Where on the anvil you hit is important as well. Now I'm leaving the head of it over the end so I don't flatten that anymore. Size-wise, it's about the same length as the other one. Now I just have to straighten it out, and then I'll have to cut it off. Before I put the head of the nail on, I need to, that won't work. So I'll use this and I'll cut it off. And I gotta be careful not to leave too much metal for the head. and not too little, because it'll just drive it right through. And it won't have any head on it. Yep, that's about it. So I heat up the round part, maybe a bit of square, and I'll just leave enough metal over the end of this. When I cut off the steel, I'll just leave enough metal afterwards that I can collapse it down to make the head. It goes through to that point, and there's that much to make the head. At this point I'll have to start using tongs. So you always have different tongs for every job, as you see. So I'll just heat this up again. I'll put the nail down through the hole in the anvil, and then the excess I'll hit on the top, and it'll flatten it out to form the head of the nail. And try not to leave your tongs on the hot metal, because you don't want to be reheating the steel in your tongs, especially if you're quenching. Eventually you wear out your tongs very quickly. So I'll try it through the hole once. If it doesn't go far enough, I'll actually hammer it out a little. That might be a bit much. That might be a bit much steel to make the head. Almost too much. So just a bit, because if I make it too small, I won't have any head at all if it fits right through. Not completely square, it's almost a rectangle, so it's not sliding through. You see how quickly it cools down now, though. That'll be good enough. So now I need to get it red hot. So it's almost like Play-Doh at that point when I put it in there, put it there, and through the hole and down. It won't take a hard hit or anything make the head of the nail. There. Then I may hit it at a bit of an angle to make sure it doesn't go through first. There we go. I mean, a bit too small. It's ready to go through the hole, not enough for the head of the nail. I don't normally think about things so much. Ever. So the head of the nail is probably going to be off to one side instead of flat all the way around like a rose head nail, because I had narrowed it down too much. I could go through the effort of making it thick again by hammering it, but for the sake of time, I'll just leave it like this. So the head is a little lopsided, but that's basics of a nail. Now it wouldn't normally take me that long. Just go ahead and do it. I could do another one, but I don't think that makes sense. Is there any? Did anybody ask me any questions?
Where's the gloves?
Where's the gloves? They're right here. Like I said, when I was learning, the instructor told me, first time you go to the forge, you'll burn yourself, and it'll hurt a lot. Next time you go to the forge, you'll burn yourself, and it'll hurt just as much, but it won't bother you as much. And the next time you go to the forge, you're going to burn yourself again, and it'll bother you less. So, eventually it just bothers you less, but it still burns every time. Now, what everybody usually asks me about is the knives. Since I got a bit of time, twist up a railroad spike, but no, that's going to take longer to heat up. As long as I'm using the tongs and long steel, I don't usually use a glove, but I'll use the gloves if I'm going to be near the hot or the fire's out of control or something like that. I'll put a glove on so I can move the fire around, but honestly, it's mostly scar tissue on the hand now, so it doesn't burn as much. So the leg place is usually always part of the triangle, and the leg place, I think you see, I don't know if you can see it at all. It's just that. It has a leg so all your force goes into the ground. And the idea is, if I had a workbench with a vise on it, every time I hit something, the bench would tip and shake and everything else. But with the leg vise, you gotta have one if you're going to be doing. Clamp the metal in, and I can hammer as hard as I want, and all that force will go into the ground instead of shattering a bench or whatever else you have there. So that's why usually if you find a forge, you'll see like the forge triangle, like I was saying. It's the forge, the anvil, and it's all kept close enough so that it doesn't cool down as you're using it, go back and forth and back and forth. So for archaeological reasons, I assume that would be an identifier if you're wondering what was a forge. And definitely there'd be clinker around. I get buckets and buckets of it, and it just comes out like stone. But every time you start the forge, first thing you have to do is pick out all your clinker from the last time you were in the forge. And because if not, it'll keep burning, and it gives you those sparks that I was talking about. Steel is burning, and when it's the actual clinker that's burning. So you have to pull it out every time, and it'll reduce the heat because it's taking up some of the space that you would want for your coal. So I will it's a twisting tool I made. Just welded a handle on top of a pipe wrench. So you put the steel in your vise, tighten it up, and you twist it. So what started out as a regular railroad spike, now all of these are smaller than what I have in the forge right now. But the one I have in the forge is about twice that thick as the steel. But you'd be amazed at how quickly or how easy it is to twist steel. Now I usually use a different vise for twisting, but that's out of the camera range, so I'll use this one. Hopefully you can see that on camera. Right, can you see the, just take it, tighten it. I could probably turn it with one hand if I,
You can see that, you can see what's right now.
can't see?
If I move it.
So easy to twist. You could probably do it with one hand, even as it cools, but as it cools now, it gets harder. But I can still twist it quite easily. And use time. See all the slag popping off? Take a brush. So you can see how easily to put a twist, usually just for decorative reasons. But I would usually clean it up a lot more, or I would hammer it first and draw it out longer to have a longer handle on a knife. But any decorative steel, which happens a lot, you see it's twisted up. And it's really physically not hard to twist. Once it's hot, it's almost like, it feels like Play-Doh. It's literally that easy when you twist up steel. Now I don't want to quench that either. Since it's the handle, but I will put a little bend in it. Too cold to be doing that. Now I'll heat up the other end and I don't know, shape up a knife. Usually any steel I have left on the forge is always considered hot steel, because in a minute or two they're the exact same color, cold steel and hot steel, so anything on the forge is considered hot steel. And I do get more slag and sparks with these, so I will put my left glove on. I can't really hold a hammer with the glove on. I need to get to know a left-handed blacksmith, and we can change gloves. I'm sure they have a bunch of left gloves that are not all burnt up. Now this thickness of steel obviously will take a lot longer to heat up than the nail would. Break it up. I think that the steel usually gets to about 1200 degrees when it's that yellow. So especially on a blade, you always have to work the steel really hot. If not, you will build in cracks into your steel. And I'm not a bladesmith, so that's just very basics. But I can see some sparks coming up. That would be terrible for a blade, but I think it's my clinker that's burning there. Yeah. Need some of that out. Okay, so you can see that even that thick steel still moves pretty quickly. So try and get the steel to the same thickness, even the tip, so that when I'm heating it, it'll heat about the same temperature. But now I'll put it all the way through, heat up this part of the steel, and then I'll draw the steel out this way and make the blade a bit longer. So you put it all the way through the fire and leave the tip sticking out. These tongs I made especially for the railroad spike, so the head of the spike can be in this gap in the tongs. So when I'm working on the blade end, the head of the spike can be in there. Usually you make different tongs for every job. That's why you see so many tongs in a lot of forges. And in an old forge, you can see what kind of work they did by looking at the tongs that were there. So again, I'm just working two sides to stretch it out. trying to keep it even as I go. So it's the shape so far. Just after 2 heats, it's almost too bright for the camera. So I try and keep it the same thickness as I go so it doesn't burn. Now I think I'll leave it at that end, and now I'll just shape out the blade. Usually I take a lot longer on doing these as well. I'll draw out the handle first, but I need different tools and different setup as I go, so for the sake of time, I'll just do it this way. So now I got to be careful that the tip doesn't heat up and burn. I'll just put some metal in there and burn it just so you see what it's like. So I just stuck another piece of metal in the fire. I'll let it go, and you'll see the sparks. There's a lot of things you have to think about in your body geometry, the way you stand, the way you hold your hammer. It all makes a big difference in the longevity of your ability to be able to blacksmith, because if you hold your hammer with your thumb on the handle or stand too straight, a lot of different things, if your anvil's not the right height, you won't be able to do it for very long in the run of a day or in the run of your life. And the face of your hammer, if you're going to hit there or here, if you want it on that side of the anvil, there's a lot of things that you need to learn, either by mistake or go into a class or a bit of both. So a lot of the blade work is actually grinding. So I'm pretty close to the shape that I want. And then there's the distal taper. So you want it narrower here and to get wider as you go on the blade. You could grind that out, you could hammer it out, depends on how thick your blade is going to be. This is going to be a pretty hefty blade since it is a railroad spike. And I do have oil and water to quench. It's a thick blade, so I will quench in water. But I'll pull this out and see if you can see the sparks. I have a bit of sacrificial steel in the forge. You're pretty far away, so I'll really let it burn so you can see the sparks that come from burning metal. When you see these sparks, metal's pretty well gone. I think it'll still spark when I pull it out. Those sparklers got the metal burning. If I was to hit it, it's cooled off a bit now, but and that's what a burnt bit of steel would look like. It's probably too bright to see. Got jagged edges. There's not much carbon left in it. It would be useless as a knife. Now there's many other things you can do with the steel if you want to work with it properly for a blade. Annealing the steel, bringing it to temperature, letting it cool down. But for the type of what I'm doing here, I'm just going to go directly in and quench it. In water. Now I could quench it in steel so everybody sees a bit of flame. But in oil so people see flame, but there's no need for what I'm doing. And when I'm heating, I gotta make sure it's the same color all the way. Nice and bright. Most bladesmiths will just buy steel for a knife, and they don't have to really hammer it, they just cut it to shape and grind it, which is not what I do. That's a bladesmith, and I'm far from a bladesmith. Oh, there are tongs. Yeah, that was a nail I had made. This time I'm making a knife. I'm thinking the whole video is going to be there afterwards to watch from beginning, but I have no idea about the whole thing, so we will see. So now I'm trying to heat up mainly the blade edge, not the back of the knife, because that's what I want hardest. That's it. I'm only quenching the blade, and you got to move it around because the water right next to the blade actually doesn't. It heats up and then it doesn't cool down, quench the blade. So that's it. Let's see. It just slides along. Yeah, the spine, it does stick back there as it should. Let's see the blade. Oh yeah. That's the sound you want, just slides right along. That shows it's hardened. And I like the fact that the spine is not that hard. I tried to keep that out of the water somewhat. So that's basically it. That's how quick it cools off. You can grab it with your hand. Now, not the other end. So it's a lot of, after this, it's just a matter of grinding it and shaping it and sharpening it and cleaning it up. And that's pretty well it. Initially it would be just a nail, but that's the most basics of the forge. I'll show you my bellows that I have. That's an old wheelchair that's on the bottom. That's going to be for my remote forge. And a few projects and ideas this summer. So at the end of it, I just turn off the air. And if I don't have enough coal coked up for the next time, what I would do is, before I turn the forge off, I would coke up some more coal so that when I come to start the next time, I already have coked up coal to start forging with right away. That'll turn into flames any second. And that's it. If anybody has any questions, feel free to contact me. Hopefully it worked.